Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So this week we will learn on the continuous probability distribution. So for today we are going to focus on two distribution, which is exponential distribution and normal distribution. For the exponential distribution, it is related to Poisson distribution. Okay, we have learned before on the Poisson distribution where it is a discrete probability distribution and it describes random occurrences over some interval. For example, we have time or it is based on space. Okay. Meanwhile, for the exponential distribution, this exponential distribution is a continuous probability distribution and it describes the times between successive events in a Poisson process. Okay, this is the example of the difference between Poisson and exponential. Okay, before this, in Poisson distribution, we learn to find the numbers of cars, the probability of number of cars passing a toll gate in 1 hour. But for the exponential, it's like an inverse of the Poisson, where we want to find the number of hours between car arrivals. Okay, it is between the time per car arrivals. Okay, another example for Poisson, we want to find the probability of number of students arrive at library in 1 minute. Okay, so the interval is in time. Okay, but for the exponential, we are more focused on the probability of number of minutes between the new arrivals at the library. So that's the difference between Poisson and exponential. So in general, Poisson is the events per single unit of time. Okay. Meanwhile, for exponential, it is time per single event. Okay. Time per event, an event. Okay. So that's the difference between Poisson and exponential. So suppose a series of events satisfying the Poisson model occur at the rate of lambda per unit time. Let the random variable x denotes the interval between consecutive events. Then our x has the exponential distribution where we can write it as x follows exp, represent the exponential with lambda. With the following probability density function, given f of x is equals to lambda e to the power of negative lambda x for x greater than equals to 0 and lambda are greater than 0. Thus, when we integrate f of x with respect to x, we can simplify that the probability of x that is less than x would be equals to 1 minus e to the power of negative lambda x. And for the probability of x greater than x equals to e to the power of negative lambda x. So let's just show you to prove this, simplify. So let's say we want to find the probability of x less than x from the probability density function. Here we know that it will start from 0 up to x values lambda e to the power of negative lambda x, where this comes from the probability density function of the exponential distribution. So if we try to solve this, you will get lambda e to the power of negative lambda x over negative lambda, where the intervals start from 0 up to x. So here, if we cancel these two, we get negative e to the power of negative lambda x. And then we substitute with 0. Here we have e to the power of 0, which is equals to 1. Negative 1. So if we simplify this, you get 1 minus e to the power of negative lambda x. Meanwhile, for the x greater than x, so here will be x up to infinity e to the power of lambda e to the power of negative lambda x dx. So here you will get over negative lambda from x to infinity. So cancel these two. So the interval starting from infinity e to the power of negative infinity. So if we e to the power of negative infinity, as you can see, it will be equals to 0. It is approaching to 0 minus with negative e to the power of negative lambda x, which is e to the power of negative lambda x. So that is how we make this general formula for the exponential distribution. So for the exponential distribution, for the mean of the exponential distribution is equals to 1 over lambda, and the variance is equals to 1 over lambda square, where lambda is known as the rate parameter. Another important things in exponential distribution, okay, given if a random variable is exponentially distributed, so that its conditional probability will satisfy these two formula. Given the probability of x greater than x1 plus x2, given x greater than x1 has happened, will be equals to the probability of x greater than x2. Same goes for the probability of x less than x1 plus x2, given that x greater than x1 has happened, it will be equals to the probability of x less than x2. So now let's go through the example. Let's try this example. A checkout counter at a supermarket completes the process according to an exponential distribution with a service rate of 6 per hour. So here we have our first information. Given a service rate of 6 per hour can be presented as our lambda, which is in terms of 6 per hour. So a customer arrives at the checkout counter. Find the probability of the following events. The service is completed in fewer than 5 minutes. So you can see here, this is an exponential problem because this probability that we want to find is in terms of the time taken, okay, not the number of events that happen in an interval of time. But our main focus now is that we want to find the probability of service completed in fewer than 5 minutes. Okay, and for the second question, the customer leaves the checkout counter more than 10 minutes after arriving. And the last one, the service is completed in a time between 5 and 8 minutes. So now let's try this out. So here given our lambda is 6 per hour, so but our probability is all in terms of minutes. So we have to change our lambda from hour to minutes. So which means that 6 will be divided with 60, which means that the service rate will be 0.1 per minute. So now we solve for question A. Probability of the service is completed in fewer than 5 minutes. So it will be x less than 5, where for x less than 5, using the general formula for the exponential distribution, for x less than x will be 1 minus e to the power of negative lambda x. Or if you want to use the integration is also applicable. So let's try this. Let's solve this first. So 1 minus e to the power of negative lambda, okay, where lambda is given as 0.1 and x is given as 5. So it will be 0.3935. Or if you want to solve using the integration, it will be from 0 up to 5. Lambda, where lambda is 0.1, e to the power of negative lambda x dx. So here solving this, it will be over negative 0.1, where the interval starts from 0 up to 5. So you will get negative e to the power of negative 0.1 times 5 minus with e to the power of 0, which is 1. And you should get the same answer with the previous solution. Okay, now we solve for B. The customer leaves the checkout counter more than 10 minutes after arriving. So it will be probability of x greater than 10, which is equals to e to the power of negative lambda x. Given that e to the power of negative lambda, which is given as 0.1, x is given as 10. So you will get the answer, which is 0.3679. Or if you try to solve using the integration, so greater than 10 meaning that it starts from 10 up to infinity, which is lambda e to the power of negative 0.1 x dx. So e to the power of negative lambda would be 0 minus with negative e to the power of negative 0.1 times with 10. So you will get 0.3679. And for C, the service is completed in a time between 5 and 8 minutes. So here to find the probability between 5 and 8, where you can find this equals to x less than 8 minus with probability of x less than 5, where the general solution for x less than x would be 1 minus e to the power of negative lambda times with x given as 8 minus with general solution for this one is also 1 minus e to the power of negative 0.1 times with x, given x is equals to 5. So 1 minus with 1 would be 0. So here would be e to the power of negative 0.5 minus with e to the power of negative 0.8, and you will get 0.1572. Mean that the probability of the service is completed between 5 and 8 minutes is 0.1572. Okay, now let's try another example. The number of hits on a website follows a Poisson process with a rate of 4 per minute. So here, our rate of 4 per minute means that it is our value of lambda, given lambda is 4 per minute. So what is the probability that more than 2 minutes go by without a hit? So our problem in A is also in minutes. So which means that we don't have to change our lambda since our lambda is also in minutes. So now for A, we want to find the probability that x greater than 2, given our x is number of hits per minute. So what we can do, using the general solution for P x greater than x, which is equals to e to the power of negative lambda x. So you can just straight away get the value of lambda, which is 4 times with x, obtained from here, which is equals to 3.3546 times with 10 to the power of negative 4. Okay, next question. If 2 minutes have gone by without a hit, what is the probability that a hit will occur in the next minute? So here we have the conditional probability problem. Given that 2 minutes have gone, so what is the probability that a hit will occur in the next minute? So for B, we know that 2 minutes have gone. What is the probability that a hit will occur in the next minute? So we can write this as x. Okay, we want to know the probability that a hit will occur in the next minute, which means that 2 minutes have gone. So x, 2 minutes have gone. The next minute would be plus 1, given that 2 minutes have gone. So x has gone, meaning that x greater than 2. So using this condition, which satisfies this formula. Okay, so I just rewrite back for B, which is x less than 2 plus 1, given that 2 minutes have gone, so x has passed 2 minutes. So for this case, it falls for the first formula, second formula, x less than x1 plus x2, given that x greater than x1, so which is equals to the probability of x less than x2, given x2, for our case, this is our x1, this is our x1, so our x2 is 1. So using this one, we want to find the probability of x less than 1 minute. It will be 1 minus e to the power of negative 4 times with 1, which is x. So your answer will be 0.9817. Okay. So this is the probability that a hit will occur in the next minute. So now let's try exercises. You can pause this video and try out by yourself, and later we discuss. Suppose that commercial airplane crashes in a certain country occur at the rate of 2.5 per year. So given that our lambda is equals to 2.5 per year. So what is the probability that 4 or more crashes will occur next year? Okay, so you can see here that our problem focus on finding the number of crashes in the next year. So this is a Poisson problem. So we want to find the probability. So given our x is number of crashes in year, so we want to find the probability that x greater than 4. So here our problem is in terms of Poisson, because we want to find the probability of 4 or more crashes. So x greater than equals to 4. So since it is a Poisson, so we can find it by 1 minus probability of x less than equals to 3. Given lambda is equals to 2.5. Okay, using the table, you will get 1 minus 0.7576, which is equals to 0.2424. Okay, the next problem, what is the probability that the next 2 crashes will occur within 3 months of one another? So here our focus is that we want to know the crashes within 3 months of one another. So 3 months, which means that this problem in a month, in months, but our lambda is per year. So first of all, we have to change our lambda from per year to per month. So our 2.5 will be divided in 12 months. So we will get this 0.2083. So to find the probability that within 3 months, okay, we will have 2 crashes. So it will be x, or we can use another random variable of y less than 3. So here will be 1 minus e to the power of negative lambda x, which is 1 minus e to the power of negative lambda given as 0.2083, and our x is given as 3. So your answer should be 0.4647. So please try another exercises and try to get the same answer like the provided answer.